Hi guys, it's Miss Bonlander. We're going to try out our first lesson virtually today. A couple pages of notes to go through, some vocabulary to fill in, and then you'll have kind of a few problems to try on your own as practice today. So we are starting a topic called polynomials. You guys watched a very short video yesterday that introduced the idea of terms. So over here, these are each labeled a term. You also talked, and we've talked in the past, that this would be considered a coefficient. Here we have an exponent. Okay, so we're going to kind of talk about different names we have for each of those. Some vocab to start for us is that idea of a term. So if you look at our example, you should notice that the terms are separated by two operations only ever. So term is separated by addition and subtraction. The constant is at the end of our polynomial there. The constant is a term that has no variable. So in this case, in this example, we'd have 7 would be our constant. Okay. Now we have something called standard form. And our example is already actually in standard form. Standard form is writing the polynomial from largest degree or exponent, we'll talk about that in a second, to smallest. So our example is already in standard form because if you look at our very first term up here, our exponent is a 2. Here our exponent would be 1, and here we said this really is an exponent of 0. We could write this as x to the 0 power. Okay, we don't have to, but we could write it that way. So that's what makes that our constant then. The last thing we talk about is the degree. And the degree for each term is the total exponents and then the largest degree term is the degree of the polynomial. Okay, so let's take a look at some examples here. So on our first couple examples, we are just going to be looking at writing it in standard form and then determining the degree of each expression. So we have to check to see if it's written from the largest term to the smallest term. So here we have an exponent of 3, of 2, and then of 0 because that's our constant. So this one is already in standard form. So I'm going to put already standard form. I'm going to abbreviate that for us. And then we have to talk about the degree. So when I talk about the degree of it, it has to be the largest degree of each term. So this one here has a 3rd degree, 2nd degree, and 0 degree. So the degree of the entire polynomial is going to be 3 because that's the largest one. Okay, let's try B. On B, same idea. Now this one's a little bit different because I have more than one variable in here. So this has a degree of 3. This one actually also has a degree of 3 because there's 1 x and 2 y's, and then this is a degree of 0. That being said, this isn't quite in standard form then. Since alphabetically x, y, y comes before y, 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 we should rewrite this as negative 13xy squared plus 6y to the 3rd minus 8. That would actually be our standard form. As for the degree, even though these are tied, it'd be the same thing. So this one would also be degree 3. On example C, if we take a look at that, we look at our degrees first to make sure if it's in standard form or not. This is a degree of 1. 2 and 0, so we have to put those in the correct order. So this one in standard form should be 9x squared plus 15x plus 2. Then if I look at my degree, the degree of the very largest term over here is 2. So we'd say this has a degree of 2. Our last example for just this topic, I'm going to extend my page here. We're going to check those degrees again. So if I go up here, this is just a y, so this is degree 1. So I have a degree 1, degree 3, and a degree 5, excuse me. So to write this in standard form, 18y to the 5th plus 48y to the 3rd, and then we'd have our plus 19y. Our degree then is going to be the degree of the largest term we wrote up there, so this would be degree 5. Hoping that makes a little bit of sense, where you have one more thing to talk about when we're classifying these polynomials. So if we take a look at our next page, another way that we can classify polynomials is by the number of terms it has. So if you look back at our very first example, if I click back, this here is our very first example. It's really asking you how many boxes do we have there. So this would have 3 terms in it. I'm just going to write that up here. So this would be an example of, maybe I'll write it up here. There we go, 3 terms. So let's talk about the names for these then, okay? So there are special case names for some of these. So these are funny words, trust me. This one here is a monomial. That's any time it has one term, okay? So I'm just going to make up some examples for these. So a one term just means there's no addition or subtraction. So it could be something as simple as 2xy. That's really just one term because there's no adding or subtracting around it. And then 2 terms, just like you would ride a bicycle, this is called a binomial. 2 terms. Bicycles have 2 wheels, so binomial. This means there is going to be addition or subtraction, so it has to be 2 separate terms. So here I could use that same example, 2xy. Now I just need to make sure I add or subtract something from it. So maybe I'm going to add 3y. And most of you are pretty smart, so you probably figured this already. 3 terms, what would be a bike with 3 wheels? Trinomial. So a term with 3, or a polynomial with 3 terms. Again, I'm just going to stick with the same ones I've had. And it just means now you have to add or subtract something from that as well. And our last one is called a polynomial. So it's that overarching name that we've already talked about a little bit. And a polynomial is going to be 4 or more terms. So if I stick with my example here, I just need to add some sort of a constant or something behind it. Okay. So you have specific names for one term, which is a monomial, 2 terms, binomial, 3 terms, trinomial. But anything more than that, there's no specific name. We just categorize it as a polynomial. Let's do a few practice problems with this then. So first, we have to make sure it's in standard form. Then we're going to classify it by how many terms it has. So if we don't see any addition or subtraction, we don't have to worry about standard form. And it's only one term, so we would call this one a monomial. Down here, if we talk about our degrees from earlier, this is a degree 1, degree 0, so we're good with standard form. This one has 2 terms, so I'd call this a binomial. On the next one, if we look at our terms, we have degree 6, 4, 2, 1, and 0. Those all go in order already, so we don't need to worry about standard form. And we have 5 terms, and we said 4 or more is just called a polynomial. Couple more examples, and then you'll have a couple to try in your work page, your practice page tonight for homework as well. So let's take a look at our degrees again. So this one's 2, 1, and 0. Perfect, it's already in standard form. And since it has 3 terms, we would call this a trinomial. Good. E is on here, so we can kind of talk about this idea that we used earlier in the year. Something we should notice about these two terms before we can classify, we have to see if they are like terms. And we're going to spend a lot more time on Friday's notes with like terms. But if they are like terms before we classify, we have to make sure we combine them. So just to review, like terms means that they are the same variable. In this case, y, and they have to have the same exponents as well. In this case, they're both raised to the first power. Okay, so before anything, I'm going to have to add those together. So I'm going to add those together, so I really get 19y minus 7. And then notice we're good on degrees. It's degree 1 and 0, but it's changed from a trinomial, which we may have originally thought, to now a binomial. And that is why we have to make sure we combine like terms before we classify polynomials. Last example, if we take a look at f, we have to see if it's in standard form. So let's talk about these degrees again. This has a degree of 2. This one actually has a degree of 4. So I do need to rewrite this one. Put this in standard form. This would be negative a to the 4th minus 7b squared. It's all set. They're not like terms, so we don't have to worry about what we did in the last one. And then this would also be a binomial. Awesome. So the last question just asked you to talk about if things were in standard form or not, and we kind of already did that as we went through the problems. So we don't have to worry about this one as much anymore because we already wrote them if they weren't in standard form. Our two examples that we did have to do that for were E and F, and we already kind of rewrote those. Awesome. I hope that made sense. If you need to go back and look at anything again, you can. Your homework tonight is you should just try those first few problems that are listed in the module. Give it a go, and then we can check and see how we move forward tomorrow.